Motorsports has always been at the forefront of innovation and technology, pushing the boundaries of what's possible on and off the track. Pioneers and technologists since the very beginning have used the racetrack to take the latest innovations coming out of commercial factories and labs, pushing them to the limits to find out what's possible and to discover what's the next piece of capability that needs to come into the race car. At the heart of motorsports is competition. Drivers and pioneers of technology taking the latest advancements and proving their value on the racetrack. Whether it's paddle shifters or ABS braking, the technologies from the lab can come to the racetrack, demonstrate their ability at the edge of the performance envelope for these incredible machines, and ultimately make race cars and regular cars safer and more performant for everybody on the roads. Since the beginning of computer science, technologists have strived to take what they're building in the labs and demonstrate its potential by competing against humans. Whether it's with the game of chess and IBM's supercomputer Deep Blue beating Garry Kasparov, or Google with the advanced deep learning algorithms for the AlphaGo project. Now, this new era, the new challenge for AI technologists is to take the sensors and the hardware and the code and use that in motorsports for the ultimate challenge, to beat a human driver. What human drivers do on the racetrack is the pinnacle of athletic performance. Taking an incredible race car that's powered by the most advanced powertrain and electronics and the tires, all of those things that are needed to get these race cars around the track at the edge of their performance envelope, and then doing that with a computer, with AI. Many people are worried about the impact that autonomous racing is going to have on motorsports. But if you look at what happened with the game of chess, and when IBM took their Deep Blue technology and beat Garry Kasparov for the first time, an AI beating a human in this game of strategy and human performance, it didn't spell the end of chess.
As a huge fan of Formula One, there are two incredibly exciting parts of making a team run. One is the driver, and fans are fascinated by the man in the arena, the physicality of it, all the decades of training that go into performing in that moment. For me, I'm attracted to the stress of being in that moment of a qualifying lap. The other part is the team and the hundreds, or for some teams, thousands of people, and all the work and R&D that goes into aerodynamic design, into how to effectively lead these organizations. So you have thousands of people that put in millions of hours of work, and it all culminates into one moment on track. That bifurcation of human effort and passion is why F1 and motorsports in general is so exciting. And so we have an interesting challenge where instead of the team and driver, all of our effort goes into the team, right? Because these guys have to solve a hardware problem. There's some software in F1, but they're primarily solving hardware problems of aerodynamics and really hard physical problems. So for us, we can put all of our effort into the team and the software. On the driver's side of that passion and fascination is, I think, the magic of being human. Our brains and our eyes and our bodies are just so beautifully complex. It's practically magic. That in these moments, drivers can make split-second decisions. Even something as complex as, hey, there's a car, 20 meters in front of me. That is just something that we take for granted. But it is absolutely magic that our brains can see, comprehend, and position ourselves in the world. So when we're looking at AI racing, the hardest problems are things like decision making and the reinforcement learning and all the advanced stuff that's going to happen. But before that, even something as simple as knowing where I am on the track, or the track layout, or there's a car 20 meters ahead of me. These are significant problems that we have to put all this engineering work into because it just hasn't been done yet. And going back to the point on how innovation in motorsport makes its way into production vehicles, knowing the position of traffic around you, knowing the state of the road, having a really good global map of where you are in the environment, these are the foundations that need to be built and so deeply trusted and thoroughly tested so that you can continue building those additional ADAS layers and fully autonomous vehicles. So as a human driver, the response times in some of the things that happen on track is just unbelievable. And it's unbelievable how your body instinctually responds to it. For me, an example is, being at Circuit of the Americas in a $5 million, race car chasing another guy, and his engine blows up and spills coolant all over the track. I'm 2 seconds behind him, and all of a sudden it's like just spraying ice, like an oil slick on the track. And we're in turn 3 and doing 120 miles an hour. And you hit that, and immediately the car starts sliding. The back just comes around. And again, going back to the magic of our bodies, like all the accelerometers and all the sensors that we were just born with, right? Those will instantly kick in and to have a response to countersteer. So it's moments like that that we need to expose our race cars to build robust systems for, so that when that technology is in autonomous vehicles, and I think in 5 and 10 years, like I don't know if my kids are gonna have a driver's license, right? Like that technology is coming. And so there's moments on track where that we need to have the hardware and software skills to determine moments like the back is starting to come around, you're going into a slide. Like, it could be an SUV on an ice slick when this is a commercialized technology, but like those moments that we get to expose the technology to on track, those make it into production cars that make everyone safer. So when we think about the world 5 or 10 years from now, when autonomous vehicles are becoming the norm, I think we also have to reflect on how transportation in general is going to change. Because I think, a 60 to 70 mile an hour speed limit as the default on the highway has been around for a very long time. And so once we're at the point where we have, these cars that can drive us around, at some point we're going to want to start pushing those limits, right? Like if we have a trusted autonomous vehicle, like why can't we do 120, right? And where is industry going to test that? So in the process of getting to that world, where is that going to be tested? And so when the moment comes that innovation is coming, not only for the vehicles, but how humans move in general, the autonomous racing teams have been working on that for a decade, so that when that time comes, we have the data, we have the technology, and it's trusted in ways that it exceed what you'd expect to see on the road. But that's the way you got to do it, right? You just have to test beyond what you think, so that everything is safer and more reliable. So as a human race car driver, I want to see humans racing on track forever. And I think we'll see that. But motorsport has never just been limited to one type of racing, right? We have Formula One. You can love Formula One, but you can also love MotoGP. You can love endurance racing. You can love, rally racing. Because there's a commonality between that of just humans with passion trying to accomplish things as a team, right? Autonomous racing is just like one more specialty within this beautiful world of motorsports. So I don't see it as competition, but I think that competition will be fun. So when we think about like what's coming up, obviously the wheel-to-wheel racing between autonomous vehicles, that's gonna be incredibly exciting, but also humans versus autonomous vehicles, the things that the human drivers will learn, the things that the autonomous vehicles will learn racing against other humans. I feel like it's really pop culture conversation right now of like humans versus AI. And I think a lot of that is hype, but being on track and literally human versus AI, that is a real challenge, and it's incredibly hard. And so I think it's so exciting for our team to work on that hard problem. And again, going back to the passion of motorsports, right? We do it because we're a team of passionate people that want to do something cool. So the human versus AI, we're definitely going to see that. And something that's personally exciting for me about autonomous racing is the journey that we're on, right? So we're in year 1, right? There's been other competitions, but I think something special about A2RL is having multiple cars on track on an F1 full GP circuit. And that is a really hard problem. And so let's say we're in year 1 of that challenge. What's year 1 of any technology, right? We look back to computers when they took up this entire warehouse and used vacuum tubes and were mechanical, right? Like that was year 1 of computers. We're in year 1 of autonomous racing. It's kind of like infants are behind the wheel right now, but we're growing to the point, and I think we're going to see this very quickly, where you're pushing the performance envelopes of a human driver. So that arc is really exciting. I think it'd be kind of boring if they just went out the gate and they immediately blew away human drivers. I think the story is way more interesting that, in race 1, that cars would lock up on the straight or break down in a corner, right? Like these are year one problems, but we're watching these little infants, and next year they're going to be walking and running, and really one of those big checkpoints is setting the same lap times as a human. Another exciting checkpoint is when the racing is exciting. The thing that really drives our team on the race side is wheel to wheel, right? Like watching Max Verstappen and Lewis Hamilton go side by side into a corner. When they crash, that's one thing, but when they can successfully execute that and push the limit and just be wheel to wheel, like I think we're going to see that very, very quickly between autonomous cars. And that's just going to be incredibly exciting. And I think that's also what's going to drive fan engagement, where it's exciting enough and they're confident enough in these AI racers to care, right? Once we have two cars going to turn one of Monza, and there's fans on both sides that care about the outcome of that chicane, that's going to be an incredibly exciting time.
Code19 Racing is the world's first pro autonomous race car team. And so we're committed to the mission of advancing the sport of autonomous racing, taking the state-of-the-art sports technology for fan engagement, on-track performance, anything that is going to make this sport sustainable and exciting for fans in years to come. Our team competes in the best leagues, the most exciting racetracks with the fastest race cars on the planet. We take the state-of-the-art technology from all the different hardware providers, tire manufacturers, sensors, compute, combine them with the best talent in the world. Like, autonomous racing is such an exciting sport that the most talented machine learning scientists and roboticists and engineers are drawn to this racing experience, to come, join a team, work hard to solve these incredible challenges that we face on the racetrack every day, build their code, test it, crash, build it better, go again, crash again. Oh my gosh, the passion, the excitement that it takes to be on an autonomous racing team and strive to be world champions is just incredible. And that the fans experience that, whether you're in the garage, watching in a VR headset, or at the trackside at these best F1 tracks from around the world. Everybody that's involved in autonomous racing feels the passion of the teams, knows that the technology on track is state of the art, and understands that for the competitors, the teams of engineers that are building and racing every day, striving to win, that the glory that comes on race day when your AI race car is the first one across the line to get that checkered flag and have the chance to lift the trophy and claim the title of the world's fastest AI. That's what drives our team. That's the mission of Code19 Racing. We are here to win.
Our team's grand vision is what we're just talking about with the wheel-to-wheel racing with other teams. That's a big part of it on the race side, and the other part is the commercialization of it, and how do we bring that into commercial vehicles to make those safer. Autonomous vehicles are coming. They're going to change the way that humans move, and we want to have years and years of practice of these and being in high stakes environment, so that when that time comes, this technology is ready to be in these cars and save lives. This is the way that that technology that is developed in racing, like stability control or anti-lock brakes, like that happens years before in racing, makes its way into commercial vehicles and saves lives. Countless lives just by those two technologies alone. If we know that transformation in transportation is coming, our goal is just to put the work in now to be years ahead. So the safety, performance, decision-making that we build on track is ready to go into those vehicles.
Code19 Racing is committed to the future of autonomous technology. We're fusing human ingenuity with advanced machine capabilities to bring a new, exciting era to motorsports that gives fans a vision of the future and what's possible in the vehicles that they drive every day.
The challenges that we have ahead in the next year, 2 years, we talked about decision making. I think that's really going to be where a ton of the effort and interest goes into. There's also these challenges beforehand of effectively using all the sensors on the car. Like our race car has as many radars as a fighter jet, right? And so fusing those into a cohesive situational awareness that humans just have and take for granted is an incredibly hard challenge. It's like a baby and their eyes developing, right? Like the most basic situational awareness. The next stage is giving it some basic racecraft. This is the part where, like with human drivers, that you put the time in to build those skills and to build that feeling in your butt when the rear end starts coming around and you got to save it. So then we have to give it those kind of basic racecraft, right? Both out on the track by itself, trying to set a qualifying lap, going as fast as you can, don't hit the wall. Like that is a great challenge in itself. And then moving on to doing that with other cars on track, with detection, prediction of where people are going, how to execute your own strategy of, warm up my tire, start pushing, be more conservative. These are all things that human drivers take for granted, but there is a lot of complexity into those decisions. And then the final part is the really advanced decision making. For example, with us, our equivalent of DRS and F1 is push to pass, right? How do you deploy that? Can you use reinforcement learning and just massive amounts of trial and error in the simulator to find unique ways to deploy that? And then there's also some really exciting things that the AI car can do that humans just physically can't do. For example, if we have control over the brakes of each individual wheel, then there's a whole world of individual brake applications to apply, a yawing moment to the car in a corner that the human only has 2 feet. You can't do it. Although there actually was a McLaren, a car one year that had a special switch that made the brakes all funny. I think it's actually a really cool example of how teams competing find ways to innovate within the rules. But that's one of the things that really excites me about F1 is when you're in that crucible of competition, you find really interesting ways to innovate that you wouldn't necessarily otherwise. The overall passion of racing, it's about teams of humans doing exciting, audacious things. And that transcends any individual type of racing, right? So in F1, maybe that's the pinnacle of R&D when it comes to aerodynamics and what they're doing with the hybrid battery technology. But with rally, right, you can be excited about the challenge of rally of not hitting trees. But from the manufacturer side, right, they're developing new suspension that works its way into, Toyota TRD trucks. You have endurance guys that you run for 24 hours, and that's just insanely useful when it comes to how part manufacturers design parts with longer longevity, the tire research that goes into that. We're not replacing those. We're just another racing thing to be excited about. And just like those other ones, we have our unique area that we get to innovate. And these other guys, it's primarily a hardware challenge, and this is the first time that it's a real software challenge. And the application is into those autonomous vehicles that are going to be super prevalent in 5 or 10 years.
The future of autonomous racing is exciting, but that's not to say there's not going to be an incredible amount of challenges ahead. It's so difficult to take the technologies that work so well in the lab and get them to run as you need them in a race car for real against other AI drivers. When you look at the sport of autonomous racing, you have the best labs from around the world competing wheel to wheel on a racetrack with the most advanced technologies. This provides a huge amount of challenges, and we're starting to realize how difficult it is, the incredible things that a human driver is able to do behind the wheel, recreating that with artificial intelligence, the fusion of sensors, compute, and algorithms. It's one of the grand challenges left for AI. Yes, the computers from IBM can beat Garry Kasparov in chess. Yes, the Google engineers have mastered AlphaGo. But the new frontier, the hardest challenge for AI, is autonomous racing. It's so amazing what a human driver can do. The athletic performance, the racecraft, the training that these humans drivers go through from a very young age. And we're trying to bring all of that capability into a technology stack, where you go from wiggles and squiggles in a human brain to the ones and zeros in a computer stack. It's incredibly difficult. What humans do on the racetrack is really amazing.
Racing and F1 specifically, a fan loves a team, loves a driver, right? You have an affinity towards this team of people or an individual. What's unique about us is it's just the team. And so a big challenge for us is sharing the magic of the team, and how for each of those teams, their unique composition of their engineers and the leaders, and the personality of that team is going to be reflected on how that car performs on track. So there may be teams that are more aggressive. There might be teams that are more conservative. There might be teams that play the long game. There might be the Max Verstappen team that they're going to dive bomb you and they're not backing out, right? And so it's going to be really cool in this league and autonomous racing in general to see these personalities evolve. And then we also have, from a storytelling perspective, how do you harness the personality of the team into the AI driver? Like Maverick, for example, she's a reflection of the personality and the composition of the team. I think we're also going to see the unique strengths and weaknesses of each team. They're going to come out. For example, teams that are really research heavy, that focus on vehicle dynamics, they're going to have a certain advantage. They're going to have a certain disadvantage. There's some teams where they have 10 sensor and perception PhDs obsessed with this problem. And their object detection is going to be very good. Something unique about our team is we believe that every engineer should also love racing and have some racecraft experience. So, we rent out tracks, we rent cars, we put our engineers in the car. They know what it feels like to, be in a 2.5G turn. They know what it's like to be on the limit. So that's like a unique composition of our team.
Autonomous racing is the next space race. Billions and trillions of dollars that are projected to be invested into these technologies over the next decade is staggering. And all of that research and development comes together on the racetrack when the teams from around the world go head to head and wheel to wheel, fighting for the chance to be on the podium with only one of them lifting the trophy, laying claim, listening to their national anthem play, understanding that all of their hard work has paid off, and they're the world champions. That's why we race at Code19. That's why we're here to win, and we want you to come with us.